Okay, geometric series is formed by adding the terms of a geometric sequence. Boom. To determine the sum of these six terms, we can do the following. So you see that if you multiply, so we've got S6, the sum of six terms, right? Which is going to be 1, 2, 3, 4, 5, 6. There's these six terms. If we multiply it by the common ratio, we kind of bump each term along, right? So the 2 becomes an 8. The 8 becomes a 32, and so on, right? And then the 2048 becomes an 8192. But these guys line up. Okay? So if we then subtract, so I've got 4 times the series minus the series gives me 3 times the series. These guys take each other out, and we're just left with negative 2 plus 8192. So that gave us 3 times the series, okay, which is and we just divide by 3, and there's the sum of the series. Okay, and so that can lead to a general method of doing that. So I've got the sum of n terms, right? So it's T1R. Okay, now what we've done is so here's the sum of n terms, sorry, this guy here, right? T1 plus T1R plus T1R squared up to the general term, which is T1R to the n minus 1. We take that series, we multiply it by R. That just kicks each term along by 1. Okay, so now these guys line up, and we've got one extra term here, and we've got a term sitting here. When we subtract, I don't know why they hide these, right? Because it's not like on your sheet, you can't see them.
Yeah. It's a mystery.
I know, right? It's like, wait, don't look. Don't look at your sheet. So if we have R of these and we subtract one of these, we end up with R minus 1 of the series. And that's equal to negative T1 plus T1R to the n. And we do a little bit of, working around here. So first we're just going to flip these guys. So T1R to the n minus T1 gives us R times this. We can factor out a T1 R to the n minus 1, and then divide by R minus 1 and get the formula for the sum of a series, right? So it's T1, the first term, times R, the common ratio to the power of n, like how many terms do I want to do, right? If it's S10, that'll be a 10, minus 1 over R minus 1. Or, again, we've got the same thing here, right? We're starting with this. R minus 1 is S. So if we look at this, T1R to the n minus T1, so this goes down here and says, well, okay, how does this become R times Tn, right? We've got T1R to the n. That comes from here. So T sub n is T1R to the n minus 1. Multiply both sides by R times Tn becomes R times this. R times Tn, this is R to the 1. Okay, multiply powers with the same base, you add the exponents, so we get T1 R to the n minus 1 plus 1. So R times Tn is T1 R to the n. So we're replacing T1 R to the n by R times Tn, right? They are the same, and this box down here shows you why they are, right? Since, gone through all this. In any case, you're going to get that form. So you're going to get 2 formulas on your formula sheet. You need to recognize 2 things. Number 1, I've got 2 formulas for the sum of an arithmetic series, right? They involve n and T1 and T sub n, and one of them involves D. And I've got 2 formulas for geometric. They both involve R. So if you think about it, what must we know? So to use either formula, we have to know R, right? That's in both formulas. What else do we have to know? T1. So if you want to get the sum of a geometric series, you must know the first term and you must know the common ratio. And then either you know the first term and the last term. So this you use if I know the last term, right? So if they say add up the series plus dot 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 right? Then you say I'm going to use this guy. And if they say, give me the sum of 25 terms of the series that starts out, then you say, all right, I know T1 and I know R and I know N, I'm going to use this guy, right? So this is, I know the first term, the common ratio, and how many terms, And this guy is, I know the first term, the last term. I don't need to know how many terms, right? Like I don't need to know n. Whereas in an arithmetic series, you have to know n, right? It's in both formulas, n over 2. We got to know n, right? We can't solve it if we don't know n. And here, we don't necessarily need to know n. All right, formulas. Use this formula if you know the number of terms, n, the first term, t1, and the common ratio. Use this formula if you know the first term, the last term, and the common ratio. You don't have to know how many terms there are. And so, determine the sum of the first 12 terms. Okay, so in this case, we do know n. All right, so let's start this off. I like to list stuff. What's t1? 5. What's r? -2, right? So all you do is just imagine there's a comma there that would say plus -10. -10 divided by 5 is -2. Positive 20 divided by -10 is -2. -40 divided by positive 20 is -2. Okay, what else do we know? N is 12, and we want to work out S12. And we don't know what that is, okay, but we're going to use the formula that involves the first term and the number of terms. So I'm going to say S sub n is equal to T1 r to the n minus 1 over r minus 1. S12 is equal to T1, so that's 5. -2 in parentheses, right, because that's the quantity -2 that you are going to raise to the power of 12 over -2 minus 1. Now in this case, since we're raising it to the power of 12, it matters that it's in parentheses, right? Because if you write -2 to the 12, like this, that answer is going to come out negative. Okay. And we don't want that, right? We want -2 to the 12. Notice how I say that differently? -2 to the 12, -2 to the 12. So you don't say that. So I'll say -2 quantity to the 12th, right? Which means it's the quantity -2 that's being raised to the 12th power. Not the negative of 2 to the 12th, right? So this is the negative of 2 to the 12th, and this is -2 quantity to the 12th, right? In other words, take the quantity -2, raise it to the 12th. Anyways, if you're doing this in your calculator, don't put a negative in. Just say, I know that's going to be a positive, right? So why not just do 2 to the 12th? All right, so we can work this out. 5. 2 to the 12th is 2, 4, 8, 16, 15, 16, 17, 18, 22, 6, 5, 12, 10, 24, 4,096 minus 1 over -3, which is whatever it is, right? It's like 4,553. What's it work out to? No. Yeah, well, you did it wrong. Yeah, your bracket's the wrong place. You're gonna go 5 divided by, or sorry, 5 bracket. I mean, you don't need to go 4096 minus 1. Surely you can do that in your head. So it's 5 times 4,095 divided by -3. Right. See, I knew it was bigger than what you said it was, because, you know, look, what do we got? We got like 20,000 over 3. That's like 6,000 something. Right? In this case, -6,825. So, that's why you want to have your calculator out and be working this out, right? If you're going to make mistakes, make them now. Right? And then look at it and say, wait, but I got a different number. What did I do wrong? Okay? Whatever. Did you get the right answer?
Yeah.
Good.
I thought you wanted it step by step.
Oh, sorry. No. Whatever. Who cares? It's arithmetic at that point, right? It's a calculator exercise. We've done the heavy lifting. Got a question? Or? No? Okay. Determine the sum of the geometric series. So in this case, what do we know? What's T1? 1458. How many years was that before Columbus sailed? Okay, 1492, 32 years, 34 years. It was 34 years, right? Declan, 34 years. He was looking for it, but he missed. What else? What's N?
We don't know.
Yeah, I don't know. What's T sub N? 2/9. What's R? What's that, like 1/3 or something?
Sure.
Well, you said 3, so I figured, it's got to go in 3 times. But remember, it's 4, it's a third, right? It's going down. If it was 3, we'd be going from 1458 up, right? So use that as a bit of a back check. When you figure out your ratio, if it's less than 1, then the numbers should be going down. If it's greater than 1, they should be going up. So if you reverse it, it's just sort of like, wait a sec, that can't be right. And what do we got? We got S sub n, right? So S sub n, we want to find. Do we care about n? No, we're not asked to find how many terms there are. We're asked to find the sum. So we have a formula for the sum of a series, which involves, so S sub n is R, T sub n minus T1 over R minus 1, right? So at this point, it's just a calculator exercise really, but we substitute in. So S sub n is equal to 1/3 times 1458 minus, 1/3 times 2/9 minus 1458 over, what was our 1/3 minus 1. Alright, just try this in your calculator. Stick it in, get an answer. Right, like, I don't think I necessarily need to see 27 intermediate steps here. Well, okay, 1/3 of 2/9 is 2 over 27. Minus 1458 is, minus 14, whatever, who cares?
On the unit system, we have like a formula sheet with all the formulas for the series and sequences.
Gotta memorize none of them, because it's all in the formula sheet. But you have to know which is which, right? So it's not going to say, T sub n is equal to T1 plus n minus 1 times D arithmetic sequence. It's just going to say T sub n is T1 plus n minus 1 times D. And you're going to get S sub n. You're going to get 4 formulas for S sub n. 2 arithmetic, 2 geometric. We're not going to say, hey, these are arithmetic and geometric, but really, we've got an R. And it's geometric, and if it doesn't have an R, then it's either got a D or a T1, Tn. But the geometric, you must know R. Okay, what'd you get? As a reduced fraction.
It doesn't go, let's do a fraction.
Say what? Really?
So it's 2186.8.
I got 19,682 divided over 9.
1968. 1968. Although it's 19,682. All right, so let me pull out a calculator and let's see what we get. Hang on, whilst I pause. You got one of the charges, you charge it before the test, right? Like sometime on the long weekend. Okay, so what do we got? Bracket 1 divided by 3 times 2 divided by 9. 9 minus 1458.
I have an old calculator.
Okay, now at that point I'm just going to hit enter and then go divided by, and I can do this maybe I can't. So 1 divided by 3 bracket, actually if I'm going to do that, let's throw another bracket in here. So bracket, so this is the bottom, right? It's the numerator, and I'm going to go 1/3 minus 1, right? And then math, enter. And it doesn't do it.
Mine did it. I have an old one though.
It doesn't simplify.
I have one from like.
That's the answer.
No, it does though. It's 19,682 over 9. So some calculators did it and some didn't. So, okay, I'm wondering, what if we did the whole thing as 1?
Yeah,
I already tried that and it didn't do anything.
So 1/3, 2 ninths, minus 1458. So that's the top, and that's all in brackets, divided by, and now I'm going to do, double brackets is to separate the top.
No, yeah.
Okay, so that's the 1/3 times 2/9. This is the top expression enclosed in brackets, right? Because this fraction bar means evaluate the numerator, evaluate the denominator, so I'm about to do that now, So I'm going to go another bracket, 1 divided by 3 minus 1. Okay, so this is the denominator. So evaluate the numerator, evaluate the denominator, then do the division. And let's just say I want it as a fraction. So before I even hit it, I'm just going to say convert that to a fraction. And it still doesn't.
That's so weird.
Okay, so here's the deal. I will make sure using this calculator that if we ask for it as a fraction, it really does. And if it doesn't, just say, here it is. Just write it all out. And now you can kind of do it, right? Because if you reckon, what's 0.888888889? It's 8/9. Okay, so if that's 8/9, then I can take 2186 divided by 9. Say there's, no wait, 8/9. So 2186, never mind. I just, oh yeah, sorry, yeah. What you can do is take 2186 times 9, right, plus 8. So there's the 19,682, right? But you have to recognize that 0.88888 is 8/9, and then say, oh, so the denominator is 9s, and yeah. How else do you do that?
I'm not gonna try and do that.
Yeah, I'm just wondering if we got the 1/3 times 2/9 minus this. Nah, I don't know. Yeah, I don't want to waste. Don't want to waste time. But you could work out. You could work out this separately as a fraction. Work out this as a fraction and then multiply, right? But I don't know. Is it worth it? All right, determine the first term of the geometric series if r is equal to 5 and s7. So we know r, we know s7. So what else do we know then? We know that n is equal to 7, and that t1 is what we got to find, and that t7, well, sorry, we don't know t7, right? Okay, so we're asked to find t1. So which formula involves nr, s sub n, and t1? Right? So we've got the formula s sub n is equal to t1 r to the n minus 1 over r minus 1. Okay? So you're communicating to yourself and anybody else who happens to be peeking in that this is the formula I'm using, right? And T1 is what I have to find, but I know everything else, right? I know R, and I know N, and I know S sub N. So now we fill in. Okay, I know this. Negative 58593 is equal to T1. That's the thing I want to find. 5 to the power of what? 7, right? Because we know that N is 7. Minus 1 over 5 minus 1. Okay, so let's do a nice detailed solution of this, right? We'll just sort of go through a number of steps. So negative 58593 is equal to T1. Okay, so what's 5 to the 7? Probably not going to do that in your head, right?
78,125.
78,125. So this will be 78,124, right? Because 5 to the 7th minus 1. Over 4. Okay, so we multiply both sides by 4, then divide by 78,124. Okay, so multiply by 4. What do we get? We got a 2, and then a 7. What is it? 2, 3, 4, 3, 7, 2, and it's negative, right? Is equal to T1 times 78124. Divide both sides by 78124. And what's T1? Negative 3. Okay, negative 3. Now you can check that out by going back here and going negative 3 times 5 to the 7th minus 1 over 5 minus 1 and seeing if you get negative 58593, right? Don't do that in the middle of the test, do that at the end. Say, I got some time now. If T1 is negative 3, then if I plug in for T1, I should get S7.
So, I have a question.
Yeah.
If from the start we just isolated to make the equation say like T1 equals and then we filled everything in, would
Sure.
We can do that?
Yeah.
Sweet.
Yeah, it's just so so it's solving this for T1 is what you're saying. So I've got
Yeah,
S
so
sub
like
n.
that's what I did on here. And then it worked out.
So yeah, so this is your next line, right? Okay, so T1 is equal to this. Now I plug in, and then I get T1. Yeah. What do you think I care about, right? I care about this. This is what I'm looking for, right? So I'm marking. So now it's going to say determine. What's determine mean? Show your work, right? It's going to say determine and wants me, you got to show your work. So what am I looking at? Hey, they got T1 is -3. We have an answer. Now, is there work that backs up that answer, right? And if it's like, oh look, there's a whole pile of, I don't know what the heck they're doing here, and then it comes out as -3, right? Because you used a calculator or something, I don't know what, right? But I mean, here if you use a calculator, you're solving it. Like I don't see how you could come up with -3 if you didn't actually do it correctly. So, but there are certain questions where yeah, you could solve it graphically. So all of a sudden, like, oh, and the point is this, right? And I said algebraically determine. It's like, no, 0, right? Like there's nothing here. Okay, this one you can't really do. A Super Ball. Everybody familiar with Super Ball? Super Ball, it's a very very elastic ball, so you drop it and it bounces. So it'll bounce up to 70% of its previous height, right? So you think about, I drop a basketball and it's like, and it just dies pretty quickly. Drop a tennis ball, bounces a few times, but it doesn't come up to 70% of its height, right? So if I dropped it from this high, it'll bounce up this high, right? So it's called a Super Ball. It's named after the Super Bowl. It was developed around that time. And they crushed a car with one. They had one the size of a bowling ball they dropped off of a building, I think, and it sort of did a car and did a number on a car. So, well, they decided it was going to bounce, right? But sort of there was some initial forward velocity when they threw it off. So when it hit, right, you don't change the horizontal component of your velocity. It'll still be moving at whatever. So it sort of bounced, and then it bounced, and then somebody probably said, "Oh my." Or words to that effect, because it's heading for that car. It's like, boom. There's a Wikipedia page. I'll pull it up in a minute. We'll do this first. So Super Ball is dropped from a height of 10 meters. And it bounces up to 70% of its previous height. Determine the total vertical distance the ball has traveled when it hits the floor for the 4th time. Okay, 4 times. So you know what? I will draw the entire bouncing sequence, like all 4 times, right? Just good to visualize and say, okay, what are we dealing with here? Okay, so here's 10 meters, and it's dropped. It hits the ball, hits the ground for the 1st time, 2nd time, 3rd time, 4th time. Okay, so and we need this total vertical distance, right? And we can see that some of these guys are repeated, right? Like it's dropped from 10, it hits, it bounces up how high? What's 70% of 10? 7. So it goes up 7, down 7. It goes up, what's 70% of 7? 4.9. Seriously? Come on, it's just 7 times 7. So it goes up 4.9, down 4.9. What's 70% of 4.9? 3.43. You guys are just slow. Okay, it goes up. You could actually just sit down and add them all up, right? You just go 10 plus 7 plus 7 plus 4.9 plus 4.9, right? But, we want a way, like, what if they said the 10th time or the 12th time? I can't do those in my head, right? So we have a formula, right? We can sum up a series. But here's the deal. Now we actually have 2 choices at this time. So we can say, all right, what is this, right? So the sum that I want is 10 plus 2 times 7, right? 7 up, 7 down. Plus 2 times 7 times 0. How do we want to do this? We could say 2 times 10 times 0.7. So that's the next term in the series, right? We'll pretend we don't know that 7. So that's this guy, right? 2 of these guys. Plus 2 of 10 times 0.7 squared. Okay, so that's these guys. Plus 2 of 10 times 0.7 cubed. Okay? So we could brute force it, but that's not really algebraically determining, right? That'll get you an answer. So if we just say, if it was a multiple choice question, what's the distance of travel, you did that, you're fine, you'll get the answer. But there's got to be a better way. What if they said the 8th bounce or the 10th bounce or the 95th bounce, right? This thing's going to keep bouncing, right?
So, well, eventually it's going to.
Yeah, eventually it'll stop. So we have a choice to do. We could say, all right, look, I'm going to add up a series. Now, how many terms am I going to add up? So let's say we start with the 10. So term 1, and let's just add up the going downs, okay? Okay, so there's term 1, term 2, term 3, term 4. So we're adding up 4 terms, right? So n is 4. The first term is 10. The common ratio, what's 70%? 0.7, right? Now, if I do that, I'm only adding up the downs. So what we're going to do is we're going to double that, right? We're going to take 2 times the sum of the series with 4 terms, and then minus 10, right? Because we'll take it in 2 tenths. Okay? Your other option is to go 10 plus and just do this 3 times, right? You just do a series of 3 terms starting at 7, but that's a bit of a pain because it leaves out the 10 and stuff. So we want 2 s sub n, well, s4, minus 10, right? So we want the sum of 4 terms. We want to double that because we've got the up and the down, but there was never enough 10, so we're going to subtract off the 10. Okay, first one, does that make sense? Okay, that we're going to add up the series of 4 terms, right? So we're looking at it as, I've got 4 terms, right? 1, 2, 3, 4, right? How do I know there's 4? Hit the ground first time, second time, third time, fourth time, right? So there's 4 of them. We want to double that because we know we've got the up and the down, but there was no up originally, 10, so we subtract off the 10. Okay, so this is what we're aiming for. Let's just work out S4 first, then we'll double it and subtract 10. So first we're just going to do S4. Okay, so S sub n, and we got to figure out, well, we know how many terms there are, right? So we can use the formula. Which formula are we going to use? Luckily, you have a formula sheet with the formulas on them. Right? So we've got the T1 r to the n minus 1 over r minus 1. Okay, so we want to work out S4. S4 is equal to T1, which is 10, R, which is 0.7 to the power of 4, minus 1 over 0.7 minus 1. Okay, now I don't even care if that comes out as a decimal, right? Because what are we going to round this to? Say round to its 4 times. Well, we'll go like to the nearest hundredth or something. So let's see what we get. Let's plug it in. Okay, calculator, slide over, on, clear. Okay, so up top. Now either I work out the top separately and then just divide it by negative 0.3, right? Or I could do the whole thing at once. For me, I'd rather just work out the top separately, like it's easier. That's just me though. 10 times 0.7 to the 4, pop that down, minus 1. Okay, divided by, now you know it can't be negative, right? So we are going to end up dividing by a negative, so divided by, and I don't trust myself to do 0.7 minus 1, so we'll just enter 0.7 minus 1. It's like 25 point, okay, so that seems to be exact, 25.33. So S4 is 25.33. So the distance we want, so we need 2 times 25.33 minus 10, okay, which will be 50.66 minus 10, or 40.66, and we need units, meters. Okay, so 40.66 meters, right? So we figured out the distance of 4 terms, starting at 10, and then going with the common ratio of 0.7. We got the 4 terms, we got that sum. We have to double it because there's the up and the down, okay? And then subtract 10 because we never did the initial up 10, right? It just started at 10 meters high. Okay, is there more? One more. Do we do that one, or I guess it's something.
From the textbook.
From the textbook, example 3, page 52. The Western Scrabble Network is an organization whose goal is to promote the game of Scrabble. TM.
What?
Trademark.
There's an entire.
It offers internet tournaments throughout the year that WSN members participate in. The format of these tournaments is such that the losers of each round are eliminated from the next round, and the winners continue to play until a final match determines the champion. If there are 256 entries in the Scrabble tournament, what is the total number of matches that will be played in the tournament? Well, okay, what do we need? So there's 256 matches in the first round. How many matches in the second round? Half that, 128. Next round? Half that, 64. Next round? Okay, so we want 256 plus 128 plus 64 plus, and how many matches in the last round? One.
Is that how many players?
Well, no, that's matches, right? Oh, sorry, 256. Yeah, you're right. Okay, how's that? Yeah, better? It's good. Somebody's on the ball. So if you're right, if there are 256 entries, then there will be 128 matches, which will eliminate half the people, or 64. Then we have 64, and so on. So what's T1? What's R? 1/2, right? What's T sub n? And what's S sub n? What's n? Who cares? We don't need to know. We just need to know the total number of matches. Okay, so there's an n equals, right? N is, don't care. Okay, what's the total number of matches? All right, so we got a formula for that, right? S sub n is equal to R T sub n minus T1 over R minus 1. Next formula sheet, RTN minus T1 over R. Yeah, okay. R, 1/2. T sub n, 1. Minus 128 over 1/2 minus 1. Okay, so we got 1/2 minus 128. Scooch that down. Oh, skills can. 0.5 minus 128. Negative 127 divided by negative 0.5. So just double that, right? So 255. 255 total matches. So there are 255 total matches. I see a pattern. What's the pattern? What's the answer? What if there were 512 players? How many matches? Yeah, 511. What if there were 1,024 entries? 1,023. That's just gonna be one less than the thing answer.
Because one guy's eliminated.
Oh, yeah, and then
Yeah.
one.
Well, half the number eliminated, but you play that way. It's an interesting fact of that particular geometric sequence or series that it adds up to that. Okay, done.